Introduction. Often, macro-level systems that are made up of large numbers of very simple micro-level elements following very simple rules exhibit unexpected macro-level properties or behaviors. Unexpected in the sense that these properties or behaviors are not analytically derivable. They cannot be predicted without simulation, even if we know everything there is to know about the micro-level elements and the rules they follow. You are driving on a highway. Suddenly, the traffic slows down to a crawl. You creep forward for 10 minutes, expecting to see a crash or roadwork. But then, the road clears up. No accidents, no police, no obstacles. A traffic jam is an emergent phenomenon. An unexpected macro-level state emerges on a road with nothing interrupting the free flow of micro-level cars. Emergence is everywhere. This is indeed fortunate because it gives us a chance of being able to model and predict the macro-level world around us, albeit often with limited accuracy and over limited timeframes, even though we have radically incomplete information about it at the micro level. As physicist Sean M. Carroll states, properties like temperature or wetness or irritability do not apply to individual particles, but are useful emergent features of the macroscopic world. Emergence provides the foundation for people and other biological organisms to have agency, to pursue long-term goals in a complex, changing environment. Without the emergence of macro-level patterns, we'd need to perform impossible calculations about how things will evolve at the micro-level before deciding whether to cross the street. This article covers the following topics: how complex macro-level structures and processes emerge from the simplest micro-level setups. The behavior of some simple, deterministic systems is not analytically derivable. Determinism refers to the world's rigid rules, whilst analytic derivability refers to knowing in advance, without simulation, what will happen when the rules are applied. How emergence across successive micro and macro levels gives rise to a layered reality. Fundamental physics governs particles, but those particles organize into atoms, which organize into cells, which organize into organisms, and human organisms into societies. Each layer has its own emergent rules that cannot be analytically derived by considering the layer below. Covering these topics is necessary before, in the next article, we can properly consider the self, consciousness, and free will. Complexity from simplicity. To shatter the intuition that simple causes produce simple effects, you need look no further than Rule 30. This is a one-dimensional cellular automaton. The setup is almost laughably primitive. You start with a single black square within a line of empty squares. For every step forward, the state of each square on the line is determined solely by its two immediate neighbors and itself. The physics of this universe consists of just 8 lines of code, a lookup table that fits on a post-it note. Unexpectedly, Rule 30 explodes into chaos. While the left and right edges retain a semblance of order, the center column descends into a riot of pseudo-random noise. It is so statistically random that, for years, it was used as the random number generator in the software Mathematica 2. This is the first lesson of emergence. Complexity is not an ingredient you need to add or design in. It can be a consequence of interaction. You do not need complex laws of physics to get a complex universe. You just need simple laws that can iterate. Computational irreducibility. There is a deeper, more unsettling lesson from Rule 30. If you want to know if the center cell as Rule 30 plays out is black or white at step 1,000,000, your intuition suggests there should be a shortcut, a mathematical formula where you plug in the value of 1,000,000 and get the answer. But for Rule 30, no such formula exists. The system is computationally irreducible. The only way to know the future of the system is to run the system. Rule 30 is strictly deterministic. If you run it multiple times, you get the exact same random pattern each time, which is why we refer to it as pseudo-random. Yet, it is not analytically derivable because the only way to find out what happens at a given step is to let the system evolution play out fully. We are forced to watch the movie play out frame by frame. Skipping to the end is impossible. Chaotic systems. While the gravitational dance of two bodies is a predictable waltz and can be captured formulaically, adding just one more object creates a chaotic system for which no general predictive formula exists. For three-body prediction, we must rely on step-by-step computer simulations. Yet, these simulations afford limited predictive capability. This is because chaotic systems are exquisitely sensitive to their starting conditions. The tiniest rounding errors in a computer's memory will eventually compound, causing the simulated reality to diverge hopelessly from the physical one. While Rule 30 and the three-body problem both defy the shortcut of a simple formula, they do so in different ways. With the three-body problem, the culprit is chaotic system dynamics, where microscopic differences in initial positions grow exponentially to shatter any long-term forecast made via computer simulation. In contrast, Rule 30 exhibits emergent complexity. Rule 30 spontaneously generates pseudo-random patterns no formula can capture. Layered reality. The following describes our reality. The best fundamental models, general relativity, governing space-time and gravity, quantum field theory, and the Standard Model, describing fundamental particles and forces, have tremendous predictive power at the most fundamental micro-level. But a myriad of fundamental interactions give rise to the complexity we observe at several higher emergent levels. The Standard Model dictates how electrons and nuclei interact. These interactions lock together to form stable atoms. And here, a new layer emerges: chemistry. Chemistry cares about bonds and reactions, not quarks and gluons. It has its own rules, emergent from the collective behavior of the particles beneath it. In turn, chemical complexity, particularly the self-organization of carbon-based molecules, provides the necessary platform for the emergence of biology, with phenomena like natural selection, cellular homeostasis, and metabolism. Finally, the biological emergence of self-aware, communicating organisms establishes the conditions for social history, an emergent level of reality governed by complex causal properties like social memory, language, economic systems, and cultural laws that arise from, but are not described by, underlying biological imperatives. Also, our reality is computationally irreducible. Since the universe is the fastest computer capable of simulating itself, you cannot get ahead of it. The future cannot be computed ahead of the universe itself evolving. This is true even if we knew everything about the micro-level states and rules, which we don't in any event. Material is enough. We need not reach for a non-material spark to explain the richness of our experience. We simply need to appreciate the profound capabilities of interacting matter to spawn unfathomable complexity. Like that of a human brain, for example, it would take hundreds of hyperscale data centers with a collective storage capacity of a zettabyte to store a high-resolution map of just one human brain. When molecules organize into self-replicating cells, biology emerges, not as a violation of physics, but as a specific, highly structured application of it. As organisms evolved complex neural networks, the processing of information became so dense and integrated that it folded back upon itself, creating the feedback loops necessary for the emergence of agency and, eventually, consciousness. We are not non-material souls inhabiting matter. We are what matter does when it is arranged in the specific, intricate configuration of a human brain. This perspective ought not be seen as a reduction of the world, but an elevation of the potential of the physical. The potential to form structures capable of emotion was always there, waiting only for the required level of complexity in atomic arrangements to emerge and unlock it. There is no need for a supernatural bridge. The layered, emergent structure of reality, from the spin of a quark to the movement of a civilization, is a single, unbroken, and entirely sufficient explanation of the way things are. There are only patterns. On the other hand, we need to be wary of strict reductionism. We could say that a table is nothing but wood. Wood is nothing but cellulose. The cellulose is nothing but atoms. And the atoms? They are nothing but excitations in a quantum field. From this vantage point, there is no table, and the only true reality is the quantum buzz at the bottom, everything else being a mirage of sorts. But this is a trap. Imagine trying to understand the plot of Hamlet by analyzing the chemical composition of the ink. You would be scientifically precise about the molecules, but you would be completely ignorant of the tragedy. Strict reductionism offers us perfect precision at the cost of significant ignorance. This is a very poor trade-off if our goal is to understand the world as best we can. Consider matter, comprised of atoms. An atom is not a tiny billiard ball. Our best theories conceive atoms as a stable configuration of interacting vibrations in quantum fields. At the foundation, there is no stuff. There are only patterns. So, if there are only patterns, what is the metric for real? We'll use a functional definition for real. To be real, a thing must pass each of three tests. First, persistence. Does it maintain its existence as the world evolves? Second, causal power. Does it kick back? Can it influence what happens with other real things? Third, explanatory utility. Is it easier to explain what's going on with reference to it? Reasonable minds often disagree. Now, let's give this test a try. Consider the rainbow. To the physicist, the rainbow is a ghost. It fails the test of causal power. It cannot block the wind, nor can you collide with it. It is not an object, but an optical artifact, a relationship between the sun, the rain, and your retina. Physically, it is an illusion. But move up the ladder of emergence to the layer of culture and consider the shared ideals associated with a rainbow symbol. The verdict flips. Does the symbol of the rainbow have causal power? Absolutely. It unites movements. It mobilizes millions. It shapes laws. Physically, the rainbow is a trick of the light. Culturally, the rainbow symbol played a role in bending the arc of history. Given this layered complexity, we should not be surprised when reasonable minds diverge on what is real. Disagreement about the nature of reality is oftentimes not a failure of logic. More often, it is a difference in emergent altitude between those scrutinizing the atoms and those watching the storm. Furthermore, we are betrayed by our tools. Language is a code evolved for simple survival, now tasked with describing a complex, multi-layered world. We are forced to flatten complex emergent phenomena into single words like rainbow. This linguistic compression creates a fog of disagreement. Reasonable minds diverge because they are attempting to map a universe of infinite resolution using a language of limited pixels. Conclusion. We do not need magic to explain the world. We need only the relentless iteration of simple, physical laws interacting across vast scales of time and space. From the chaotic certainty of Rule 30 to the social power of cultural symbols, reality is not a single flat plane of facts, but a tower of emergent layers. Each layer, physics, chemistry, biology, sociology, is real in its own right, possessing its own valid rules and occupied by elements with causal powers. Acknowledging this layered reality dissolves the false dichotomy between the material and the meaningful. We can accept that we are made of nothing but atoms, while simultaneously insisting that we are something more than that. Emergent complexity means phenomena like good, evil, and beauty are real, even within a strictly physical universe. However, this poetic materialist worldview faces its ultimate test when we turn the lens inward. It is one thing to accept that a traffic jam is an emergent property of cars on a highway. It is quite another to accept that you, your private thoughts, your sense of agency, your very experience of being alive, are merely an emergent property of neural traffic. Is there any room left for the self? Or is the feeling of being a conscious agent the ultimate illusion? We'll consider these questions in the next article.